We're going to talk about trigonometric integrals, okay? And for this one, we're talking about tangent of x, tangent squared of x, tangent cube of x, and tangent fourth of x. And essentially, once you know these, the odd power and the even powers, then you could essentially apply this to even tangent to the fifth of x or tangent to the seventh, etc. Okay, so let's start. So what's the integral of tangent of x dx? Well, again, currently we do not know it, but we know this is the integral of sine of x over cosine of x dx. And essentially, if we set u to be cosine of x, then the derivative of cosine of this is negative sine of x dx. Well, we have a positive sign, so therefore negative du has to be sine of x dx. So therefore, if we just do a simple substitution, then we have our negative du, and this is just 1 over u, because we set our u to be cosine, and our negative du took care of sine. So we just essentially just have a 1 on the top. Okay, and if I take my integral of this, this becomes negative the natural log of the absolute value of u plus c. So we know our integral is a negative natural log of the absolute value of cosine of x plus c. Okay, and so that will be our integral for tangent of x. Sorry about that. So let's look at the integral of tangent squared of x dx. Okay, for this one, you gotta use what is called the identity. Okay, and essentially, what I'm talking about is that we could rewrite tangent squared of x as secant squared of x minus 1 dx. So this is the same thing. And essentially, this now becomes a very easy integral. And so what I could actually do is just distribute my integral sign, because this is actually being multiplied by the whole thing. So this is the integral of secant squared of x minus the integral of 1 dx, and there's my dx. Okay, we know the integral of secant squared of x. Yeah, that's tangent of x. And we know the integral of x, which is just minus, well, you know the integral of 1, which is just x. Okay, and so we get our integral to be tangent of x minus x plus c. Now what about tangent cube of x? This one's a little bit more interesting. Tangent cube of x dx. Okay, well, for this one, and you'll notice the pattern, we have to split it. We have to split it and use the identity, okay? So in this case, I could rewrite tangent cube of x as the integral of tangent squared of x times tangent of x dx. Well, now I have an identity that I could use, okay? And so this becomes the integral of secant squared of x minus 1 times tangent of x dx, okay? Now I can just distribute. So when I distribute my tangent to both, well, my integral now becomes secant squared of x times tangent of x minus tangent of x dx. Okay. Now, if you look at this, I could split my integrals up. So this becomes the integral of secant squared of x times tangent of x dx minus the integral of tangent of x dx. Okay. So if I look at this, well, for this I could use u substitution, right? If I set u to be tangent of x, then the derivative of that is secant squared of x. Well, the integral of tangent of x we just found a while ago, okay? And so I'm not gonna bother to go through the process with this again. I'm just gonna copy from here, okay? So hopefully that is okay, okay? Just to make it short on you guys, so you guys don't have to sit here and watch like 20 minutes of nonsense. And so if I set u to be tangent of x, then my du is secant squared of x dx, which is exactly what I have. So my integral now becomes the integral of u du, because du represents secant squared of x, tangent of x, and my tangent is my u. Okay, so everything is set minus negative natural log of the absolute value of cosine of x. Okay, and we're just gonna pretend like we took the integral, so we're just gonna attach on that plus c there. Okay, so now we know integral is gonna be, well, Well, that's just 1/2 u squared plus natural log of absolute value of cosine of x plus c. Well, what was my u? My u was tangent. So this becomes 1/2 tangent squared of x plus ln of cosine of x plus c. Okay, and again, you can see that I just skipped the integral of tangent of x because we already did it here. Okay, and I just copy the integral, but you got to remember, because we have a negative sign here, then we got to distribute to give us that positive natural log of cosine of x. So let's look at the integral of tangent to the 4th of x dx. Well, now that this is an even power, this is how we usually deal with even powers when we talk about these trigonometric integrals. And so I could rewrite tangent to the 4th of x as tangent squared of x times tangent squared of x dx. Okay, what this allows me to do, remember we said that anytime we have some sort of even power, we're going to use our identity. And so my integral is going to be given by secant squared of x minus 1. And this replaces this tangent squared of x. And we're going to multiply by tangent squared of x dx. Okay. Now what I'm going to do, I'm going to distribute. So my integral is going to be given by the integral of secant squared of x tangent squared of x, because I'm distributing my tangent, minus tangent squared of x dx. Okay. Now again, I'm just going to distribute my integrals, my integral sign, because I like doing that. So this becomes the integral of secant squared of x tangent squared of x dx minus the integral of tangent squared of x dx. Okay. So how do we deal with this? Secant squared of x, tangent squared of x. Well, again, hopefully you could see that this is u substitution. So in this case, if I set my u to be tangent of x, yeah, and my du is secant squared of x dx, which is exactly what I have. So secant squared of x dx, okay. And so I could rewrite my integral as the integral of u squared, because u is tangent, but it's squared, so this is u squared. And my du represents secant squared of x dx minus the integral of tangent squared of x dx. We already know how to deal with this, okay? Okay, and so my integral now is going to be given by, well, what's the integral of u to the 1/3? Well, u to the u squared. That's just u cubed over 3. Okay, minus the integral of tangent squared of x dx. And so if I look at this, well, this just becomes 1/3. And what was my u? It was tangent of x. So this becomes tangent cube of x minus, well, how do we deal with this? And I just don't want to flip the page, so let's do this but we did it already. But what's the integral of tangent squared of x? How do we deal with this? We split it. So this is, well, not split, use the identity. So this is secant squared of x minus 1 dx. Okay, and so this becomes 1/3 tangent cube of x minus, well, what's the integral of secant squared of x? Well, you know what? We got to distribute a negative first, so be careful. So this becomes, and let's distribute our equal or sign first, okay? Or integral sign. So this becomes negative the integral of secant squared of x dx plus the integral of 1 dx, okay? Because my negative gives me a negative secant squared of x and a positive 1. Okay, and so if we look at this, my integral becomes 1/3 tangent cube of x minus, well, what's the integral of secant squared of x? That's just tangent of x, okay, plus, well, what's the derivative of the integral of 1? Happens to be x plus c. And so this will be my integral, okay? And once you know all these four right here, you could take this and apply to any situation. So notice how I deal with the odd powers. When I had the odd power, I split one to give me an even, and then I use my my identity. Okay, split one to do my even, and then I use my identity. For the even power, because see, I split it into two even powers and use the identity, and then distribute. Okay, and once you know all these four, then you could use this and apply to any others.